Hey everybody, this is Gregory from Dapp University. So in this video, I'm going to be talking about how a cryptocurrency exchange works. And you might have seen some of my other previous videos where I kind of give you a high-level overview of, how cryptocurrency exchanges work. But today I'm actually going to kind of step into some code and show you what happens whenever that code is executed. So before we do that, be sure to subscribe to this channel if you haven't already and click the like button down below. That really helps these videos get found so that more people can learn how to build blockchain technology. So I figured the best way to demonstrate, how a cryptocurrency exchange works will be to look at a cryptocurrency exchange. So let's go to DappRadar.com, where we can see actually, dApps that are running on the Ethereum network, and we can see them, organized by category. We've got games and exchanges, collectibles, marketplaces. So let's go to the exchange category, and let's actually take a look at the #1 decentralized exchange right now on Ethereum, which is called Idex. And you can actually see their 24-hour volume is almost 10,000 Ether, and they've got, almost 2,000 users in the last 24 hours. So I figure Idex is a pretty good, exchange to look at since they're clearly the top dog in this space right now. So you can actually kind of, see some more information about this. You can browse this if you'd like. But I'm going to actually look at the smart contract. We can see, this is the exchange listed here. So I'm going to pull this up on Etherscan. This is the smart contract for Idex. This is you can see the balance. There's a lot of Ether. It's about 12 million US dollar. You can see the number of transactions. We can see the list of transactions. This is a pretty active exchange. So I'm going to click the code tab here in Etherscan, and we can actually look at the smart contract code. So I'm going to go through this code in a second. But in order to make sense of it, first, let's kind of take a tour of Idex, the decentralized exchange, and kind of just take a look at the user-facing features to kind of get a high-level overview of what a user might see and the features that are available and how it works. And then we'll kind of dive into the code once we have that context to make sense of how the backend works. So if I actually pull up the website for Idex, you can get that link here from DappRadar. You can just go to idex.market. So if you open this site, you'll just see, a trade view with a couple different features. We've got the markets. This is a list of trading pairs. We can see them by basically, we can categorize them by the asset that they're traded with. So this is the ETH market, which basically means these are all the assets you can trade for ETH or Ether, the Ethereum native cryptocurrency. These are all the markets they support, or all the trading pairs they support for Tether, USD Tether, which is a stable coin, and then also USDC, which is another stable coin. So you can browse this list if you'd like to kind of see what they support. Right now, we've got the Aura token pulled up. If we tour around a little more, you can see, a candlestick chart, which indicates, the trades and volume over a certain time period. We can see each candlestick on this chart represents, an hour window. The reds are drops, and the greens are, basically, the red goes down and green goes up. So it's the price. So this is not necessarily meant to be a tutorial on how to trade. It's mostly just kind of showing you the features that are here. But the heart of this, functionality, what I want to go over today is the buying and selling of assets. So this is going to be the core functionality behind the exchange itself. I mean, this is how assets are actually exchanged. So let's get a kind of basic overview of what this does. So when you're trading assets on an exchange, you basically create an order. And the order says, I either want to buy an asset or I want to sell an asset. And it's going to be based on, whatever trading pair we selected. This is the Aura and Ether trading pair. So in that trading pair, we either want to buy the Aura asset or we want to sell the Aura asset. And so we're doing this paired with Ether. So if you want to buy Aura, you must purchase it with Ether. And if you want to sell Aura, you will get Ether in return. So if I choose to buy Aura with Ether, I create a buy order. And that gets added to this order book down here. And this is the list of all the buy orders on the exchange right now. If I want to sell Aura, I create a sell order, which also gets it gets added to the list of sell orders right here. So both of these things combined make up the total order book, which creates a market. So the market has a supply and a demand. And whenever, the supply meets the demand, a trade is made, essentially. Both of these people are market makers. And in this case, the exchange is the taker because it actually matches buy and sell orders. The exchange is sort of the marketplace. It's, where the market is. And it's basically the value of the exchange is it matches orders for you. Now, you could create an exchange where, you just listed, all the buy orders and listed all the sell orders. And you could basically have people individually come and say, oh, I want to fill this order, part of it or all of it. Or I want to fill this order, part of it or all of it. But the value of the exchange is it actually matches your order with another. And what I'm talking about right now is limit orders. So you can also do market orders, but I'm not going to go too in depth into that. I want to talk about basic, kind of a basic understanding of just how orders work in general. So that's the value of Idex. It basically takes buy orders, sell orders, matches them, creates a trade, and gives the seller the asset that they want in exchange for whatever they're selling, and it gives the buyer the asset they want in exchange for whatever they're buying. So how does it do this? Well, Idex uses a combination of the blockchain and also just a centralized service to manage orders. So the trading on Idex actually, the actual trade of the assets happens on the blockchain, but the orders are managed on an order book. And they do that because basically you want to, in order to speed this process up for better user experience, you can just manage orders on a centralized server because it's faster. You can basically just create, a new order and store it in a database on a centralized server. What you're doing is you're actually signing the intent of that order with your private key on the blockchain, and it gets sort of hashed and stored in a database and then sent to the smart contract. Whenever it goes to the smart contract, it's allowed to actually make the trade itself. So if you're in here, you could sign a transaction, something like MetaMask. You basically just open your Ethereum wallet, and you could make an order and sign it. And then we get hashed and stored in the database. And then whenever the exchange itself matches your order with someone on the other side of the market, then it sends that signed order to the smart contract, and that smart contract actually does the swap. So that's a long explanation, and it can be kind of complicated at first, but I'll open up some of the code now, and we'll kind of walk through how that happens. So, like I said, the code's available on Etherscan. I'm just going to open it up in Sublime Text so that we can kind of read this with some syntax highlighting. I'll even bump the font up a little bit. Before I get into this, just know that the smart contract is going to govern basically all the handling directly of the assets, and the server is going to just govern the orders. So I should also mention that if you're using Idex, what happens is first you deposit the assets you want to trade, you assign them to the smart contract, and then whenever you create the orders and the exchanges does the matching, the smart contract is already in charge of the assets, and then it just does the swaps for you. So let's go back to the code. So inside of your, you've basically got a basic ERC20 contract that, this is a smart contract that's going to get used later. This is just the interface. So in Solidity, You can define contract interfaces. These are basically just functions that don't really have any internal wirings. It's basically going to say, we know this token is going to have all this stuff implemented. That's why it's a standard. That's why it's an ERC20 standard. All ERC20 tokens must implement this interface. And basically, we can use this contract later inside of here in order to do stuff with ERC20 tokens. And that's exactly what this is for. So next, we actually have the exchange contract. And you can see the constructor down here as well. That's going to get called. We'll go over that in a second. So inside of here, first we got a bunch of helpers. Some of this stuff looks like it's just pulled out of other libraries, like safe add, safe subtract. This might come out of like a safe math library or something like that, safe multiply. We can a helper that's just used for passing assertions. It looks like actually it's overriding assert. Or I see what's going on. So anyways, we've got. This is an ownable smart contract. So basically this will have an admin or an owner. And we'll see here in a second that it's got, some functions to assign the owner. We can get the owner, and we see a function modifier here. It's called only owner. You can see it here. Basically, this is going to say any function that has this only owner modifier attached to it will allow, it will restrict the access of who can call this function to whatever Ethereum address is assigned to the owner in this case. So we got some other stuff in here, like these mappings for invalid orders. So I don't want to go through all of that too in depth. We can see some basic data structure here. You have some mappings. These are like hash tables in Solidity. They're basically lookups. So the key is an address. The value is a Boolean. This is like saying, is this person an admin? Order fills, things like that. So I don't want to go through all this stuff like in depth. This is just kind of getting a high level overview of the organization of the code. Here's the function. Here's the constructor that gets run whenever the contract is deployed. I guess set admin is in here twice, looks like. Oh, no, sorry. Set owner versus set admin, my fault. So this right here is actually a function that's a safeguard for people sending Ether to the smart contract. If someone sends Ether here by accident, it'll just revert so that they don't accidentally just, give this smart contract Ether. Okay, so here's what I really want to focus on, which is all the functions that are related to trading. So first, we'll see this function for deposit tokens, deposit, withdraw. I want to go through these first. So like I said, in order to do trades with Idex, I believe you need to deposit your assets to this smart contract first. And then once the smart contract controls the assets, you can actually, sign the intent to trade. So we do this two ways. Idex supports tokens and also supports Ether. So if you're going to use tokens, we use this function. If we're going to use Ether, we use this function. So deposit token, if you look here, basically what's going to do is this is the address for the ERC20 token smart contract and the amount. So for example, if I wanted to, trade, an ERC20 token like OMG or 0x, I would basically pass the smart contract address in here. And this is all happening with the app, by the way. You would basically pass the token address and the amount. It's going to get added to this tokens mapping to say that like, hey, this token is, it's basically tracking balances. So we say the tokens mapping, get the address for the token, and then say inside of that, there's an additional mapping that maps to this person who sent the tokens, this account, and it's going to say, hey, add the amount here. So there's some other stuff in here that keeps track of like the last active transaction, but here's the heart of it. This token right here is the same as this token contract, which I explained a second ago. So basically what's going to happen is we're going to use this ERC20 smart contract interface at this address. So whenever we pass in the token address, we basically say, hey, go find this ERC20 token, get an instance of this smart contract on the blockchain, and we want to call the transfer from function, which is an ERC20 function, which basically moves tokens from one account to another. And it's saying move them from the person who deposited this token to this, which is the smart contract in this case, and move this many. So that's what it does. This is where the actual deposit takes place. And if it doesn't happen, throw an error, because we don't want this function to call anymore. We don't want this event to get triggered. So that's what the actual deposit does. It transfers this ERC20 token from this address to this smart contract. And now the smart contract actually has control of this many tokens for this ERC20 token. We can do the same thing with Ether. So this is for ERC20 tokens, and this is for Ether, actual just native cryptocurrency on Ethereum. So this is a payable function, which we need to use every time you're sending Ether to a smart contract, or anytime you're sending Ether to a function, it has to be payable. So same thing here. We just keep track of the tokens, and basically they're just saying use this blank address as the pointer for Ether. And then basically, the Ether is just given to this smart contract, and it'll have a balance. So that's how it works. So first, in order to trade, we assign the tokens or the Ether to this smart contract, and then it's able to manage the trades itself. So here's withdraw. This is the same kind of thing. It's just in reverse. I won't go through this in depth, but basically if you want to, remove any of this stuff, you just withdraw. Same thing for admin withdraw. This is for fees. I'm not going to go through this in depth either. All right, so here's the last thing that I want to go over, and this is basically how the trade works. So remember I said that basically Idex uses a server to manage orders, and basically it does the trades on the blockchain. So essentially, the user has deposited some tokens or some Ether, and whenever, they sign their intent to trade and it gets stored in the server, that gets sent here to the smart contract whenever the order has been, matched, and the trade actually happens. So, all that trading happens in a centralized way on the server. But now, all the matching happens on the server, and then it sends this, this intent to trade to the smart contract. And we can see, only the admin can do this, and the server is going to be an admin in this case. All right, so basically, here's where the trade happens. And we see some trade values are passed in and some trade addresses are passed in, and then some other data that's going to get used to verify the transactions. So we can see here, these are arrays, trade value and trade addresses. This is who's involved in the trade, and these are like the values that are specific to the trade. So this is, the amount, is a zero-based index array. So this is the amount to buy. This is the amount to sell. So first item, second item. When the trade expires, the nonce, the trade amount, the trade nonce, the fee for the maker, and the fee for the taker. So also for trade addresses, this is the token to buy. This is the token to sell. These are going to be addresses, that are used inside these mappings here, and the maker and the taker. So these are just some basic validations that they want to execute before the trade actually happens. But I want to go through these because these are sort of the most interesting ones that I want to call out. So basically, EC Recover, what it does is it ensures that the hashed information that we passed here actually returns an address. Basically, it's able to rebuild the address that signed a message. So what happens here is they're able to check that this is the same address with this function, which is pretty cool. Same thing here. So if you look at trade addresses 2, this is, let's see here, trade addresses 2, the maker. they're just going to make sure that the maker who signed this address is actually the same person who signed it. And that's what this does. And the taker, same thing here. Uses EC Recover to ensure that this person is actually the same who signed the intent to be the taker. So they add some information here to the traded values. We say that this, trade hash that we built right here has been traded. This is basically some safeguards, looks like, to set values if they're over a certain amount. Basically, they'll add the amount right here, trade values 4, which is the amount of the trade, to the filled orders. And yeah, so same kind of thing. We're just stepping through, like, actually fulfilling this entire order. And like, if any of this stuff, breaks in the process or like exceeds or is less than a certain amount, we just throw an error. That's kind of what happens. Pretty standard common practice. So the next thing that happens is basically it just walks through this trade. And you can kind of look through all these a little more. This would take me a really long time to actually step through each individual line of code in here. But that's what it does. Basically, it just executes the trade. You can just kind of step through this one by one. And last thing is you can see that it adds the filled amount, and then it updates the last active transaction. Feel free to look this up on Etherscan and kind of like look through this more yourself in order to understand kind of how this trade is actually executing. I know this video is run kind of long, so I don't want to keep you here forever, but I wanted to at least point you to this resource and give you kind of a basic overview of how this works if you wanted to build something like this yourself. You can build code on a server that manages orders and then build a smart contract that actually does the trades. So I hope you all found this video helpful. Leave a comment down in the comment section below if you want to see more videos about building cryptocurrency exchanges. And also be sure to subscribe to this channel if you haven't already, and hit that thumbs up button down below. That really helps these videos get found so that more people can learn how to build blockchain technology. So until next time, thanks for watching Dapp University.